Welcome back to Giro 3 YouTube channel. Let's turn this down a bit. In today's video we're having a look at a controller I'm reconfiguring from a KR680-RC into a DS-7N controller. This one will have remote output. I'll give you more of that in a minute. The controller will be for a up-and-coming KR680 DC rotator. So everything's been converted from this AC into a DC. First off, if you haven't seen other videos, the PC board has been replaced with one of my DS-7R PCBs. If you can just read there, this is a hybrid PCB that was made up for imitators, rotators and stuff, but I'm reconfiguring it to work with this Kenpro and whatnot. So basically a few upgrades that I've done to this. I'm actually running a since it's a DC rotator, I'm running a PWM I think it's a 10 amp on this one, a PWM controller. So where normally this board would have the bridge rectifier and the motor stuck and the DC cap on board, well, now I'm feeding the DC into here where I was feeding AC before. So basically, I just did a bit of a mod to this, put a couple of links in, and I was able to feed in basically. So I'm putting the bridge rectifier and the 2200 by 50 volt capacitor on a little PCB, which will then be fed by the transformer, which will then go into the PWM, and then it will go into here, and then all the control will be all taken care of from this. So this board has a lot of extra features, including the remote output input RS232, as well as the everything is controlled by the two relays. It has big filter coils on here. So basically, if you saw the other video of the building of this PCB, so it was all designed and everything, and we can do minor mods to it too. We can run either AC or DC rotators, and now I've got another option where I can have DC input instead. So let's move forward. So I've already showed you those. It will be having one of my Y-LED DC PCBs going into it for the display illumination. All this is the pre-terminated wiring that I've got ready to go into all the plugs and sockets. They're all color coded here. The green one's on here. The green one is over on in the back of here, which I'll show you in a second. So basically, I'm using a transformer out of an imitator 1200 FX rotator, FX controller. So basically it has all the voltages I need to run this. So basically that's that. The display has been upgraded as well. I've actually sealed around the edges of the lens because the LEDs will fire through the side here, and just gives better light emission. That's a big word for the day. But this controller is one of the early version controllers, which was all gear driven, not belt driven. So when you're looking there's just gears, and they're all metal gears except for the first primary gear there, which is the one just there. I'll get a finger on it. That's you probably can't. There's not much light here, but. So basically it's a gear driven, it's a servo motor, all the gearing is actually within this. So this one is ready to go. So I've actually put a late model display on because I like this because of the way it looks, and had to do some minor mods. Mainly this screw had to be moved to there. That's the only change I did. And the blue back, I like the blue back better than the later model, which is a grey yucky looking colour. So okay, the front panel has been upgraded. As you can see, I put the speed control onto here. So we have a speed control. I've also done a small mod to it so we don't go too low in voltage. I put a resistor in the line. So basically we use the standard power switch, the standard direction switches on this. The direction switches will be wired into off the which is coming up here. I might show you this anyway. So this is the back panel. I've just finished labelling it and doing all sorts of stuff with it. I've just put the 6-pin cinch socket in it. There's the remote, and there's the IC socket. So I've actually just finished labelling that. So basically this wiring is for the remote. This is where the direction switches go off these 3 wires. So you feed 0 volts in, and it can then controls via the controls the relay. So the switches aren't do not have any current on them. The relays are all taking care of the current and everything. So this is the back of the board. I've already got the standoffs for the PCBs. This one will be going in here. I will show this. This will be going in there. The bridge rectifier one is going in here, like that. I'll be able to screw down in it. But so yeah, and the other PCB, this one, and I'll be putting this. This is a late model PC board mount for imitators, and that will be mounted up there. And then this PCB is mounted down in here. I'll get it in the right position. Yeah, I'll get the eyes right, it'll be right. That'll be mounted there like that. And I'm held in by 2 screws there, and the actual mounting bracket up the top here. So there we go, that will be sitting there like that. Had to do a minor mod on the front. Just had to chamfer back this because it was getting pretty close to the front panel. So basically this is the first part of this video, so I will be going away and I will be starting to reassemble, but assembling everything and getting it ready. So I'll probably do a couple of little short videos of the assembly part of it all going back together again, or going together. And hopefully in the future I will be showing you the actual the KR680 rotator, the DC rotator that I'm building up. That'll be the next thing to do. So we'll get this done first. Need the controller before we can do anything else. A bit of a mess here now. So all good. We shall catch you in the next one. Bye. Okay, we're back. Okay, I got a bit carried away. I ended up doing a bit more than I expected to do, but once I got going I just kept going. So basically I have installed the transformer, all the screws and bolts in the bottom. I've done wiring of the IEC socket, as you can see in there, that's all wired and all the terminals are covered up. I have installed the cinch plug, 6-pin cinch plug. The cover is for an 8-pin cinch plug, but everything matches up the same. So we'll get that there like that. Oh, turn it around again. The actual main transformer is in. I mean the main power, the main PCB is in, and I plugged all the wires into that, and I did a little bit of wiring. The wiring's been done onto the bridge rectifier capacitor board, and then it's wired actually into the actual PWM. So as mentioned before, this is a little PC board bracket which was designed for this one, and I'm just setting it on the side. It normally sits down in here, but it's been repositioned and repurposed. So basically I've got to do some wiring of the meter adjustment and stuff, but and more wiring to go, of course. So I'll just put it aside. I have put the display in. I'll flare it out, and direction needles. I'll put the knob and everything on, and put little lettering on there. You can't see it, flaring out again. So I've got max and min in there. I might put an angle. So max and min written in there, little dots. I've installed my wire-led PCB, and so basically it's got more wiring to do, and yeah, so we're off and running. So that'll do it for this update, and I shall get back to you again soon. We're back. Okay, I have. Oh, I'm going to move this board a bit far away. Okay, I've finished wiring it. Whoops, just the KR or to DS7 controller for a KR680, and so basically it's all finished wiring. Let's turn it that way a bit so you can see all the wiring done on it. The wires are longer, so you can lay down the front panel for servicing and checking things out, and all the wires lay down in these positions here, so it's all looking good. Let's spin around that way. We've got to go and do all the testing now, and we shall move forward, and then we can get onto the rotator. Hooray! Okie dokie. I shall see you in the next part. Bye. Okay, we're back, and it is all together. Check this out. All screwed up, all wired. Only missing now is the top casing. We're going to take it for a bit of a drive in a second. It's come up really, really good. So basically, I've actually got the motor that will be going into the KR680. It's a DC motor, and I've got a basic wiring a potentiometer onto the plug just to emulate it working or simulate it working, whichever way you want to put it. So here's the top casing. So that was all glass bead blasted and primed and painted. So yeah, and same with the back casing on this one as well. The sub chassis on this one was done as well. So yeah, and now it's all labelled and everything, and as you probably saw before. So before we go any further, we shall plug him into some power. We'll plug the little makeshift plug into the back. Also, just got a potentiometer. I'd actually like to show the display working, but it's probably going to be washed out a bit. I'll just turn this down a bit. Bring the motor over to here. I'll put the motor on the other side so you actually can see it spinning. I put the BK butterfly on so you actually can visually see it spinning around. So just as a thing to do. So we'll just sit it there. We shall power him up. You may see the LED illumination come on because it has got LED. Wait a little bit. I'll bump the thingy. So basically we can turn the potentiometer and show it working. Slightly quicker than going around with the rotator. So, and interesting in this design, it actually gets really slow towards the end, and then it just, yeah. The motor, these servo motors are a bit more noisier, but it's better than having to deal with the bloody braking belts and stuff. So yeah. So there we are, right and left, and then go pretty fast. Not bad considering the motor on the servo motor is actually a 24 volt motor. It does get up the speed, even though it's only doing the volts is around about 12 volts coming off the display to drive it, so it does spin up quite fast. So, okay, so we'll get it back to north again. Let's see how it slows down, and then gradually walks up. Just probably just to do with that way the design was made. Okay, we're going to give it a bit of a quick run. I'm actually in low speed mode. So we'll actually see the actual, it's in low speed, you can see it stopping and starting. I may even turn it down a bit more here. I think I've got a noisy brush, because one way it's quiet, the other way it's a bit noisy. So you can see them going right and left. We can hold the button down and then flat out. The other way. the noise. So I'm going to have to, the motor hasn't been serviced yet, so I'm going to physically see what's causing that. Strange, it sounds like brush noise. So I might have a worn brush, I'll have to check that out. So one side's really quiet, one direction I should say is really quiet. One side's noisy for some reason. All good, so all proves that it all works. The display, if I cover my hands over, actually, what I'll do is I'll get a, oh my hands might do it. You can physically see the display. It's illuminated quite well, and the adjuster's in from their side, which it's a wire LED configuration, so the adjuster in there for the brightness, I've got it sitting around about half at the present moment. Half brightness. If I turn the lights out, you probably see it working really well. So it's about half brightness. So okay, that's all good. It's up and running. I can now move on to doing the rotator and everything. So that will be on another video. Totally, I'll keep all this controller ones in one video, and then when we get the actual rotator done, we'll physically do a video with both of them running. Okie dokie. We shall catch you in the next one. Bye.